Now, we can easily find AXE from supplementary angles. So we have angle AXE would just be 180 degrees minus 72 degrees minus 60 degrees, and this should be 48 degrees. Megan, do you agree with this?
Yeah, that seems correct to me.
All right, let's check the answer. Yep, 48 is the answer.
Awesome. Let's go into the next problem then. So this is going to be question number 19 from the speed round. And we're given a quadrilateral with AB equal to BC, CD equal to DA, and AC equal to BD. So let me draw that really first. Let me draw that first really quick, and we can get that. So AB equal to BC. CD equal to DA. So that's like a kite. And AC equal to BD. Okay, interesting. Did I copy that down right? That is one of the most important questions. Seems like I did. Okay, so how many of the following statements must be true? The diagonals of the quadrilateral are perpendicular. All four sides are equal. The quadrilateral is a parallelogram. The quadrilateral is a square. Okay, so, well, I feel like we can draw a shape that's going to look like this, where the centers don't match of the diagonals, but they bisect each other, right? And that will give this, both of these equal. Now, since this is a kite, we do have the diagonals perpendicular to each other, but I don't think we necessarily have that the four sides are equal, the quadrilateral is a parallelogram, or that it is a square. I think it's just the first statement. Unless I'm missing something. Aiden, what do you think?
Yeah, I agree. So these problems, they're really, really challenging because you can miss a lot of cases. And what I like to do for these problems is to just draw the worst possible shape you could think of. So in our case, we have to have the diagonals are equal. So we can draw the diagonals here. We're not going to draw them bisecting each other because that's a little too perfect. Instead, if we draw this, we know that these two sides must be the same as for these two.
Yes, and real quick, we have someone in chat saying diagonals aren't equal, but we're actually given that AC equals BD, and AC and BD are our diagonals.
Right here. Of course, you can get technical and say that sometimes AB and BC could be diagonals, or actually, no, that's impossible. But yeah, okay, there we go. So if we draw this shape, then we see that obviously this shape does not have all four sides equal, is not a parallelogram, is not a square. But because of the AB equals BC and CD equals DA, we must have perpendicularity. So I think the answer should be 1 as well.
Yeah, and it is. So that works out pretty nicely.
Awesome. Let's move on to the next question for today. This is speed number 26, actually, and it seems to be a logic problem. 5 suspects, one of which committed a crime, are being investigated. They give the following statements. Suspect 1 says, it was either suspect 2 or 5. Suspect 2 says, it was neither me nor suspect 3. Suspect 3 says, whatever suspect 4 says next is incorrect. Suspect 4 says, out of suspects 1 and 2, one of them told the truth and the other lied. And then suspect 5 says, no, both suspects 1 and 2 lied. It is also known that exactly 2 of the suspects are lying. Which suspect committed the crime? Okay, that's a lot of suspects. Anyways, for logic problems, exactly. For logic problems, If you read a textbook, what they would tell you is to look for contradicting statements or agreeing statements. So let's take a look. It was either 2 or 5. Okay, so suspect 4 and suspect 5 have a contradicting statement here. One says out of suspects 1 and 2, one of them told the truth and the other lied, whereas suspect 5 says, no, both suspects 1 and 2 lied. So we know out of these two, there's exactly one truth and one lie.
What if they both are lying?
That is another possible case. Thanks for reminding me of that. So let's see, we have 3 truths to distribute and 2 lies. So we could either have truth lie, lie truth, or lie lie. And we can just take cases now. So the first case is if suspect 4 is telling the truth and suspect 5 is lying. So suspect 4 says out of suspects 1 and 2, one of them told the truth and one of them lied. So again, we have a truth and a lie for suspect 1 and 2. So that means suspect 3 must be telling the truth because we only have 2 lies. Suspect 3 says, whatever suspect 4 says next is incorrect. And this is contradicting then. This is wrong because they're both telling the truth in this case. Therefore, this case, we can't have truth and then lie. Let's try suspect 4 is lying and suspect 5 is telling the truth. If suspect 5 is telling the truth, then no, both suspects 1 and 2 lied. That would be impossible because that means there'd be 3 liars, and that's more than 2. So this is wrong again. So finally, our only case is suspect 4 and 5 both lied. Now that means the rest told the truth. So suspect 1 says it was either 2 or 5. So 2 or 5 are our possibilities. Suspect 2 says it was neither me nor suspect 3. So actually, I'll do this in a more organized way. I'll write all the numbers and then I'll eliminate one by one. So based on suspect 1, it was either 1 or 2 or 5. So it cannot be 1, 3, or 4. And suspect 2 says it was neither me nor suspect 3. So based on this, it should be 5. But let's check suspect 3 one more time. Whatever 4 says next is incorrect. And since 4 is lying, that's true. And just to be sure, let's check 4 and 5 one more time. Out of suspects 1 and 2, one of them told the truth and the other lied. That's a lie. And then suspects 2 and 1 lied. That's also a lie. So the answer should be 5. What do you think, Megan?
Yeah, that seems right to me.
Awesome. Let's check the answer now. Yep, and the answer is 5. Awesome.
Wow, new type of problem. So this is going to be accuracy number 1. Mikhail puts his pencil at point 5 in the following picture, and he traces over the line in such a way that he traces each line exactly once and never picks up his pencil. Which labeled red point does his pencil end at? Okay. So there's actually a really quick way I can look at this and solve this, and it's a pretty interesting fact where if you're trying to do this, you can have either 0 points with an odd number of lines coming out of them, or 2 points with an odd number of lines coming out of them. And if you have 2 such points, you're going to start at one and end at the other. And the only points here with an odd number of lines coming out of them are 5 and 6. And so we start at 5 and we end at 6. So that's a really quick way to do it. Excuse me? I did not catch that, but oh well. What was I going to say? Yes, if you don't know that, a good rule of thumb can just be to start at 5 and then try to figure out something that we can do. So for example, we could go like 5, 2, 3, 1, 2, 4. Oh wait, no, that won't work. We could figure out a path, and then wherever it ends up is going to be the answer if it works. But that's going to get a little bit complicated. So I like this method better.
Yep, and just to add on a little bit to that, this is, how many people here have heard of graph theory? Because that is the foundation of graph theory. Basically, you're just checking the edges, which are the lines here. Sorry?
I don't think that's particularly relevant to the mathematics we're doing, unfortunately.
Yep, but we'd love to hear if you have ideas about graph theory. Anyways, so graph theory, and here we're just looking at, if we're starting at 5, we're going to have to go to a point and then leave a point. And since we're tracing one line exactly once, that means every point that we go to and then leave must have an even number of lines connecting to it. So that's what Megan means when she says we need an odd number. All right, next question then. And yes, the answer is 6. So we'll be going on to a team question now. This is team number 2, and it states the letters N, C, S, and M each.
Excuse me, this is getting pretty disruptive. Could you please stop?
Okay, let's keep going. The letters N, C, S, and M each represent a digit from 0 to 9, such that we have this adding expression. The digits N and S are not 0. What is the 5-digit number NCSSM? So we want to add these. Yes. Okay, no more of that, please. Back to the question. So we have this addition formula here, and 3 C's sum to a 2. So there are a few ways we could do this. We could have some carries. So there are a few possible ways. We could have C plus C plus C, starting from the 1st digit, is equal to 2, 12, or 22. We know that we know that 32, 42, they cannot happen because C is a digit, so it's less than 10. And out of all of these, 2, it's impossible, 22, also impossible. That's because the left-hand side is 3 times C. So we need a multiple of 3 on the right-hand side. And 12 is the only one there, so this would imply that C is equal to 4. Now, if we replace C as 4 in our addition, we'd see that there's one carry for the N, for the N, yeah. So now we have N plus M plus M plus 1 is equal to 2, 12, or 22. And again, since the digits are less than 10, we can't have 32 or more. If we look at this, then clearly 2 is impossible. So we have N plus 2M is equal to 11 or 21. Okay, so that's what we have for now. But now if we look at the S column, we can see that S is not 0. So S plus S is equal to 2. And since S is not 0, we have to have that S is equal to 1. So if we replace S here, that would mean there's no carry to the hundredths place. If we look back at N plus 2M, since there's no carry, then we would have to do 11. Okay, now how should we solve this? One solution that seems to work is n is equal to 1 and m is equal to 5, but n is equal to 3 and m is equal to 4
Or
also
Aiden, wouldn't
works.
that result in a carry over to the hundreds place, giving us not 2, but instead 3?
Oh yes, exactly. So my mistake right here. I think we wrongfully eliminated the 2 right here. So if we choose 2, there's absolutely no carry because 12 would result in a 1 carry. That's correct. Thanks, Megan. So this would mean that n plus 2m is equal to 1. And this would force n is equal to 1 and m is equal to 0. So this should work, right? N is equal to 1 and m is equal to 0. If we confirm,
Seems like it.
14 plus 104 plus 104, this would sum to 222. Is it possible for n and s to be the same? I think so.
Looks
It
like
doesn't
it.
say no. So, and this is our only solution. So the answer should be what is n? 1, c is 4, and s is 1, 1, and then m. My answer is 14110. Let's see what the actual answer is. 14110. Perfect. Next question.
Yep. So another accuracy question. 64 students are playing in double elimination. Each game ends in a win and a loss. There are no draws. Once a player is played twice, they are eliminated. What is the maximum number of games that can be played before only one winner remains? Okay. So we know that there are 64 students and that we need thus at least 63 times 2 losses. Make it so that each person plays 3 games with the other person. That's a good idea, but I think the issue we'll run into there is that if you get 2 losses right at the start, then you would have someone eliminated. And yes, hello, Sam. So I think what we're going to do instead is we're going to say that we're going to have 63 times 2 losses for the 63 people to be eliminated. And then we can also throw in 1 bonus loss for our winner before, so they won't yet be eliminated, but they're halfway there. And then if we add those, that's 126 plus 1, or 127, I believe. That seem right to you, Aiden?
Yeah, that seems about right. This seems like one of those problems where like, if you get it, then you get it really fast.
It's a pigeonhole of a sense, I believe. And yep, that's the right answer.
Great solution. Awesome. Okay, next question. We're back on the speed round and we're doing question 20 now. So in a basketball game, basketball is a great game. Eli attempted 4 times as many 2-point shots as 3-point shots. In addition, his accuracy on 3-pointer shots was half his accuracy on 2-point shots. If Eli scored 32 points from making 2-point shots, how many total points did he score in the game? Okay, for these types of problems, I really like to make a chart because that's what can help us be organized. So for our chart, we have, actually, this would be a very simple chart. It would be Eli and, no, this would not be that simple. So we have 2-pointers and we also have 3-pointers. And then we have made and then total. From the problem, it says Eli scored 32 points from making 2-point shots, so he made 16. Now looking back at our other information, it says his accuracy on 3-pointer shots was half his accuracy on 2-pointer shots. Okay, so let's try this. Oh, here's another piece of information. Eli attempted 4 times as many 2-pointer shots as he did as 3-pointer shots. So if we let X be the total attempts made for 3-point shots, then his total for 2-point shots would be 4X. And since we also don't know how many 3-pointers he made, let's call it Y. Now we have to use this accuracy information. So in addition, his accuracy on 3-pointer shots was half his accuracy on 2-pointer shots. So accuracy would just be 16 over 4x for 2-pointers. This would be accuracy. And then y over x for 3-point. And half his accuracy on 2-pointer shots. So now we can have that y over x is just equal to half times 16 over 4x. So we can multiply both sides by x and then cancel some numbers. We get that y is equal to 2. So if we replace y in our chart here, we have he made 2 3-point shots. Now the problem asks for how many total points did he score in the game. So that'd be 2 times 16 plus 2 times 3, which is equal to 38. Does it sound right to you, Megan?
Yeah, I think so.
And by the way, if your 3-point average is already half as good as your 2-point average, that is really impressive. Okay, let's check the answer. 38, precisely.
Awesome. Oh, this is very red. The binary operation red spade is defined as that thing. So for example, you get that. What is the value of the below expression? Interesting. Okay, that looks terrible. So my first instincts are to either see, yeah, we can find a pattern. We might get something nice with that first operand, or might be able to simplify the function as stated. So easiest thing to do, what is 1? My drawing skills are terrible. Spade 0, that's simply 0 minus 3 minus 0 plus 6, which is 3. So unfortunately, not that nice. So let's go into that second idea. Can I factor this? Well, it looks like I would be looking for the form a minus something, b minus something, then probably plus or minus something. So we have negative 3a, so that's b minus 3, and negative b, so a minus 1. Then we need to add 3 to the end of this. Okay. But then notably, at least to me, we then immediately nest that back in as the new 3, and we have, as the new b, sorry, and we have b minus 3. So, like for example, we have 2 minus 1 times 1 spade 0, which is 1 minus 1, 0 minus 3, plus 3, that all minus 3 plus 3. And since these two cancel, then we just have 0 minus 3, and then times 1 minus 1 times 2 minus 1 times 3 minus 1, and just so on and so forth. But this is notably 0. So I think, and you can correct me if I'm wrong here, I think we're going to get a lot of products. So product from I equals 1 to 20, 22 of I minus 1. And then that times -3 and then plus 3. But since this has the term 1 minus 1, which is 0, then we just have 0 plus 3, which is 3. I don't know. Does that seem right?
Okay, I see what you're getting at. I think the answer is 3. So back to a student's observation about noticing a pattern. I think the factorization helps prove the pattern basically. So if we start from 1 state 0, then the answer to this should be 1 times minus, it should be 3.
Yes.
And then 2 spade 3, if we try that again, that should also be 3. And then it goes on forever, and it's 3. So what the factorization is helping us with is that a minus 1 times b minus 3 is plus 3. If we put 3 in the b position, then we would always get another 3 for the b position. And then we would keep getting 3s for the b position because this term right here cancels out. And then our final answer would be 3. That sounds about right. Okay, let's check the answer. And it is 3. Great.
Yeah. I think there's actually another way we could do it. I don't know. We probably don't have time to. So next question probably.
Okay, then. This is a team number 4 now. How many different ways are there to write 6 as a sum of n-consecutive integers for some positive integer n? For example, 1 plus 2 plus 3 equals 6 is a way to write 6 as a sum of 3 consecutive integers. Okay, this does remind me of partitions, but they're not exactly the same thing because in partitions, order does not matter. So what I'll do here is I'll just do casework. Some positive integer n. So if n is equal to 1, we want one number that sums to 6, which would be, one consecutive integer that sums to 6. That would just be 6. So that's one way. Now for n is equal to 2, is it possible for 2 consecutive integers to sum to 6? No, because 2 consecutive integers, they would have opposite parity. So they would add to be an odd number. 6 is even though, so there's 0 ways for n equals 2. Now for n equals 3, we would have, oh yeah, Eric, that is a correct way. So like sum these up, divide by 2 is equal to x. Wait, actually, almost there, basically. You're using the sum formula, and that would be a good way to approach these cases once the numbers get bigger. So now if n equals 3, we're already given that, which is 1 plus 2 plus 3. So that's one way. Now, notice that they say the sum of n consecutive integers for some positive integer n. So these integers don't have to be positive. So let's keep going. Let's keep searching. N equals 4, we might have to start using variables now. So if we have x, which is the first term, plus x plus 1, plus x plus 2, and then plus x plus 3 is equal to 6. Then if we solve this, we get x equal to 0. And this gives us a correct sum, which is 0 plus 1 plus 2 plus 3. So yet another sequence. Now, is there more? Let's see. What if we do this in general? The first term is x, and then the next consecutive term is x plus 1, and then all the way on to x plus n minus 1 is equal to 6. Oops, okay, that's kind of hard to see. If we sum this, then we could use our sum formula. We would have half times the first number plus last number times the total numbers, which is n. And this equals 6. So 2x plus n minus 1 times n is equal to 12. And this is a Diophantine equation. So since n is a positive integer, we can only have possible n is equal to 12, 6, 4, 3, 2, and 1. We already know that 2 is impossible, 1 gives us an answer, 3 gives us an answer, 4 gives us an answer. Now for 6, if n is equal to 6, this factor would be 2. So that would give us a non-integer x, which is wrong. And then if n is equal to 12, this would be 1. And that would give us a negative x, but that's all right. That would be -5, -4, -3, all the way onwards to, this should be 6. And if we check, they do sum to 6. So n equals 12 also works. That gives us 4 ways. Does that sound right, Megan?
I think so.
All right, then let's check the answer. And the answer is 4. So this problem illustrates that using a general form is really powerful. Like, you don't want to just blindly test numbers, because if I were to just test the numbers, then maybe I would have just stopped at n equals 4. I wouldn't have gone all the way to n equals 12. But n equals 12 does have a solution there. So luckily we did that. On to the next problem.
Whoop. I love this. How many ways are there to arrange the letters in the word potato such that all of the O's come before all of the T's? Interesting. Okay. So, well, one easy way to do this, O, O, T, T. And then, shoot, or is this gonna work the way, this might not work the way I think it is. Okay, let's do it this way. Just to arrange the word potato, we have 6 factorial over 2 factorial times 2 factorial ways to do that, because there are 6 letters and O and T are both repeated twice. And so that is going to be 180 ways to do it. Now, in terms of where the O's and T's end up, there are 4, choose 2 ways for them to be relatively ordered, but only one of them has the O's before the T's. So I think if we divide this by 6 and get 30, that should be our answer. Does that seem right to you, Aiden?
That sounds about right. But I think your first method also had potential. Like, symmetry, definitely the intended method there.
Well,
but
yeah, 'cause I was thinking about the where is it? Here we go. That stars and bars method, where you lay down the stuff and you put them in between, but that would have gotten a slightly more complicated.
I think so, but actually what if we think about it just as fixing the O's and the T's? As
Interesting.
in like the
Yeah.
O's and the T's would not move.
Uh-huh.
Then if we want to choose where P goes, there are 5 slots for the P.
Right, yes.
So that'd be 5 ways for the P. Now, if we put the P down just anywhere, we could also put the A anywhere. There's no restrictions. So this time there's 6 spots. 1, 2, 3, 4, 5, 6. So there would be 6 ways for the A. So our answer would be 5 times 6, which is 30 as well. I would have gone with the symmetry method, but after seeing the answers do match, this is also a valid way.
Yes. And then if we check, they both match the actual answer. So that's always a great sign.
Great. Let's go on to another speed problem. This time it's speed number 27. Okay, we're getting to the hard end now. Let n is equal to 2022 to the power of 22, which is a big number, of course. How many positive integers m are there such that m is a divisor of n and n is a divisor of m squared? Okay, we have a huge number here, and we're talking about divisors. So that would prompt us to factorize 2022. So 2022 is equal to 2 times 1011, which is a multiple of 3. So 2 times 3 times 3, and then 337. And 337 should be a prime. So now n would be equal to 2 times 3 times 337 to the power of 22. And we just get a normal number now, not as scary. To the power of 22. Now we want to find integers m that are divisors of n, but then n is a divisor of m squared. So clearly m cannot have any other prime factors that aren't 2, 3, or 337, or else we'd have problems. So let's just write for a moment the general form of m. M could be 2 to the power of I times 3 to the power of j times 337 to the power of k. It seems that we can actually use the exponents and translate the problem into just a problem about exponents. So if m is a divisor of n, we would have I is less than or equal to 22, j is less than or equal to 22, and k is less than or equal to 22. Of course, I, j, and k are positive, no, not positive, non-negative integers. And then if we look at the other condition, n is a divisor of m squared, then we would have 22 is less than or equal to 2i. Same thing here, 22 is less than or equal to 2j. And then right here, 22 is less than or equal to 2k. Now we're getting somewhere. So if we rewrite these, combine them, we would get I is less than or equal to 22 and also greater or equal to 11. And same thing here. So we have 11, 22, 11, 22. Now, finally, there are 11 choices for I, 11 choices for j, and 11 choices for k, which should be equal to 1, 3, 3, 1. That's a pretty big answer. Does that seem right to you, Megan?
Huh. I mean, it doesn't surprise me that it would be.
Isn't it 12 choices? Okay, yeah, Eric, thanks for pointing that out.
Yeah, I was gonna
My
say, I think you
addition
might
and
have gotten
subtraction.
your equality strictness a bit confused.
Yep. So thanks for pointing that out. We actually have 12 times 12 times 12, which this is harder to calculate. So that should be 1728. Okay, does that seem right now?
I think so.
All right, then let's check our answer. 1728, exactly. Take it away, Megan.
Yeah, that was a very good explanation. Oh yes, and do not worry about making mistakes. They are incredibly common to make.
Yeah, I also put 1331.
Okay. Isaac, Albert, and Eli are attempting to guess Harley's secret number, which is 1 through 12. So they each get a guess and it cycles back. Nobody ever guesses a number again. What's the probability that Isaac is the first person to guess the secret number? And then, of course, we do the small amount of finagling. Okay. So the chances that Isaac gets it right is 1 over 12, or that he gets it right the first time. Shoot, let me pull that down. Isaac, Albert, and Eli. And then Albert has a 1 in 11. Eli has a 1 in 10. But this is reliant on the 11 in 12 chance that it was not guessed previously. So that's actually equal to 1 in 12. And same over here. We have 1 in 10, but now there is a 2 in 12 chance it was guessed previously. So we multiply it by 10 over 12. Notably, we don't simplify that because we are going to immediately get 1 over 12. And this pattern will continue of it being 1/12 for each of them as it goes on. So the answer is simply 1/3. And so the answer we give is 4. Then there's actually another way we can think about this where we order their infinitely many guesses, or not infinitely, order all 12 of their guesses. And then the chances that like the number 1 showed up in 1st, 4th, 7th, or 10th would be 1/3. So yes, this should be the answer, right, Aiden? What do you think?
I think so, yeah. It's kind of counterintuitive. Like, I think one
Yeah.
of them would have an advantage. But honestly, if you think about it more, I guess it does make kind of sense.
Yeah. And up. There we go. 4.
Correcto. Okay. We're on to speed number 30. Holden creates a sequence of numbers by starting with a of 1 is equal to 2021 and setting a of n is equal to 20 plus a of n minus 1. If n is even, oh, so this is only if n is even. Okay, I see where we're going. And a of n is equal to 21 a of n minus 1 if n is odd. What are the last 2 digits of a of 2022? That's a lot of big numbers again. So in these problems, there's really nothing I can do right now. So find a pattern. That's what I'm gonna do. Let's try this. If a of 1 is equal to 2021, since the next term is 2 and 2 is even, we add 20. So that'd be 2041. And then now we alternate. So we're going to 21 times 2041. And then we add 20 again. So
These seem
actually,
like
I'll write
they're
it.
going to get to be gnarly numbers.
Yeah, I'll write it without evaluating. So this will be 2021 plus 20. And then we'll have 21 times 2021 plus 20. And then 21 times 2021 plus 20. And then plus 20. Okay, So luckily, we're only trying to find the last two digits of A of 2022. So let's keep track of the last two digits now. We have 21, and then we have 41. And then since we're multiplying by 21, what's 21 times 41? Let's see. 21 times 41 is 41. 82, which would be 861. So 61. Okay, this is actually getting nice. And then we would have 81. And now after we add 20, it's time to multiply by 21 again. So we can do 81 times 21, which is 26, which is 01. And then we add 20 again. So 21. And then we multiply by 21, which again, we get 41, and then 61, and then 81, and so on. So this pattern is repeating, and that's good. So we're cycling with a period of 5, starting from 21. Since 21 is the first term, we can take, so these are 3, 4, 5, and then at the 22nd term, that has a remainder of 2 when divided by 5. So it would match to this term. And 41 should be our answer. Does that sound good? Let's see.
I think so.
Is there any mistake in this proof? All right, I don't think so. Do we want to check the answer?
So.
All right, let's see the answer. 41. Okay, that's a relief.
Yes. Okay. Oh no, we have geometry up next. That was such a nice question you had. Now we have geometry. Come on now. Okay. We have square ABCD with semicircles drawn outside it, diameters on the sides. We then draw a line parallel to BD and tangent to the semicircles. What is measure XAY? Okay, that's not too bad. Okay. So, Okay, I want a bigger diagram. We're getting a bigger diagram. That's not a square. I mean, it is if we try hard enough, but we're not trying that hard. Amazing. Perfectly perfect, as all geometry should be. Okay, so we have these 2 points. And the first thing I want to do is I want to see if there's anything we can do with the midpoints of these circles. I can't work with this diagram. Let's get a new one. Okay. 1. Nope. 2. 3. That's at least a bit better. Now we can draw the circles, similar triangles. That might, what did I just click there? Similar triangles might be useful. If I can spot them, that is. Okay. And then, of course, our line over here is parallel to this line. And should also be perpendicular to the radii when they go, or tangent line perpendicular to the radii there. Okay, so that's at least getting somewhere. This angle and this angle. I mean, the way this is drawn, these look like equilateral triangles. We know that these four are all equal, but we don't know that these aren't equilateral, are they? Okay, here, let's call this X. And so that means that the square length is 2x, and that's going to mean that our diagonal is 2x root 2, and thus this length would be x root 2, if I'm not mistaken.
Megan, I have an idea.
Yeah.
What if we connected the points, which are like, draw the parallel line to DB and XY, but that pass through the 2 points where the circle centers are. And then since we have a square, maybe we would have 45-degree angles.
Sorry, can you say it one more time?
Here, I'll draw it on my screen real quick.
Yeah, sounds good.
So if we have the centers here and the radii here, what if we connect this line here? We could get, this angle would be 45 degrees, and maybe we could use that somewhere.
Oh, good point. Oh, because that would make this angle also 45, wouldn't it? And then since it's equilateral, then this angle is, well, 180 minus 45 over 2, which is what?
An ugly fraction.
It's an ugly number. I think it's 7.5. So that's this angle and this angle, and then add 45 to that because of the extra angle, and you get that. So our answer should be 45 plus 67.5, which is 112.5. I think it's kind of ugly. Oh, integer. That's oh, that's because they're not supplementary, are they? No, what we'd have to do instead is you take, so our big angle that we're trying to find is, we have 90 here, and then the two isosceles angles, and then we're left with that one. So 360 minus 90 minus 135 is simply 135 again, I think.
Yep,
Geometry
I agree.
is ugly.
Yep, but I agree with the answer of 135. Awesome. Okay, do we want to do another problem? Let's see. All right, let's do this problem. Oh, let's do one last problem because it is 5:04 Eastern, but we'll do just one more. All right, so for team number 10, find the number of ordered triples of integers a, b, and c with these conditions, such that, a lot of conditions again, a minus b is a multiple of c, b minus c is a multiple of a, and c minus a is a multiple of b. Okay, this will be fun. Modular arithmetic. All right, so this is number 3, so modular arithmetic could be applicable. I'll write it in, since C divides A minus B because A minus B is a multiple of C. So just FYI, this line symbol here, that means divide. So A divides B minus C, and B divides C minus A. Now, what can we do here? Let's see. So if we want to do, this is symmetric, so we might want to preserve the symmetry for sure. How about if we transfer this into modular arithmetic, we just have A is congruent to B modulo C, and I'm not sure if that will help too much. With A is less, so we actually have pretty tight conditions. A, B, and C must be between 1 and 0. So
1 in 10.
1 in 10, my bad. We could try a few things. Let's see, what if we set C is equal to, let's set A is equal to 1 and see what we can do from there. C divides 1 minus B. Okay, I already see a problem. Because if C divides 1 minus B, then actually, that should be fine. Let's keep going. 1 divides B minus C, which is obvious, and B divides C minus 1. Now, take a look at this. We could actually write this as C divides 1 minus B minus C, because 1 minus B is a multiple of C, and then B divides B plus C minus 1. And the observation here is that these two are just additive inverses or negatives of each other. So B and C both divide B plus C minus 1. How does this help us? Megan, do you have any ideas for how we could go from here?
Huh. The only thing that comes to mind is, well, equality is obviously going to be a really nice solution because everything divides 0. And equality also preserves symmetry. And I'm wondering if the symmetry might mean that equality is the only solution.
That's an interesting thought. Okay, let's try this out then. This wouldn't hurt. What if we said something like, something crazy? We said A is equal to B. Let's just try that. If A is equal to B, then C divides 0. That's obvious. A divides A minus C. And B, we can replace that with A. So A is equal to B in this case. A would divide C minus A. Okay, so they actually give us basically the same thing. What if, but this would mean that C has to be a multiple of A.
Yes.
C multiple of A. And in that case, that's all that needs to be satisfied then. If A and B are equal to 1, we have 1, 1, then if C is a multiple of A, there are 10 ways for C. If they're 2, 2, that'd be 5 ways. 3, 3, that'd be 3 ways. And we could keep counting. So this is definitely a way. But we still have to worry about like proving that A must equal to B, or is there other solutions involved here?
I'm curious, what would the restrictions be on, like if we consider the largest number, right? Then there's probably an upper limit on what the largest value can be if A is not, if A and B aren't equal, there's probably a limit, like of like 5, not even 5. There's definitely there's a limit of less than 5 where the largest number has to divide the difference of the smaller two. Maybe it is a bit above 5. There's a limit somewhere, I believe.
I think so. That would be something that might be feasible.
Or wait. Okay, wait, no, you can't, because the difference of the smaller two numbers is always less than the largest number, right?
The difference of the smaller two numbers is always. Could
Because
you
it's
repeat
less
that?
than, yeah, okay.
Oh, okay. I see where you're getting
Yes.
at.
So we have A less than but not equal to B, less than but not equal to C. B
Yes.
minus A is less than B and is less than C. Thus, C cannot divide B minus A.
Oh my God, you're a genius. Okay, I see. Okay, that makes so much more sense. That
Well,
is an
yeah,
amazing
it
idea.
can't unless it's 0. And we've said that it's not 0. So all it's left to do is to consider equality cases.
All right, so that is genius. Oh my God, you eliminated a whole case of things being not equal. So we're left with 4 cases. We'd have A is equal to B, not equal to C, and 3 times this, because we have permutations, and then 1 times A equals B equals C. So, all right, back to what we were doing earlier then. If A and B were 1, then right here we got that C is a multiple of A and B, so A divides C. Therefore, we would have 10. All right, I'll make this a little bit neater. So we have A divides C. So if A and B were 1 and 1, then there'd be 10 ways. 2 and 2, that'd be 5 ways. 3 and 3, 3 ways. 4 and 4, you'd have 2 ways. 5 and 5, that would be 2
But don't
ways.
forget, these are also the ones where C isn't B. So it's
Yes.
1 less in all of those.
So that would be 9, 4, 2, 1, and 1. And then all these, since they're 1, this would all be 0. So sum this up, we should get, that would be 17. Now, A equals B equals C, I think they all work because 0 is a multiple of everything. So that'd be 10 ways. So if we do 17 times 3 for the permutations and then plus 10, we would get 61. And I think that's the answer, right?
I think so.
Let's see. Yep, the answer is 61.
Woo!
That was a beautiful idea, Megan. Yeah, this problem, it's just the equality case and noticing that you can't be a multiple of something that's less than you unless it's, yeah, less than you, not even 0. All right, Megan, do you have anything to add?
Not really. That was pretty fun.
Great. Back to Professor Loden.
Wow, I just wanted to say that was incredible. See, actually, during this live stream, I was also watching. I was actually setting up a bunch of things to let us simulcast across a lot of services. But while I was looking at how we were doing this last question, I was also thinking, how do you do this question? And watching Aiden and Megan just reminds me of why I'm not the one that you should be listening to. You should be listening to that. Well, thank you very much for coming tonight or today or whatever time it is for you. If you like this learning style, come follow our YouTube channel and you'll be able to keep seeing things from interesting people like them. Or if you like this way of teaching, we also run our summer classes, which are coming up, which I've taught in this exact same way. With all of that, thank you all of you. Congratulations to the North Carolina organizers for making such interesting questions. And have a great day. We'll sign off. Bye-bye. Bye-bye.
That's pretty fun. Also, Victor is correct. Professor Lowe's lights are pretty cool.
For sure.
Yeah, thank you guys so much. Hope you had fun.